Monica?
Yeah, yes, sir.
So everyone has, sir, 1 second, sir. Everyone has facing this installation problem. So once after this presentation, you can able to show them how to install the software.
Okay,
So
okay, sir.
maybe if it is possible today, you can start the hands-on. Otherwise, you can you can do it the entire session by tomorrow.
Okay, sir. Okay.
Okay. So, sir, we are going to start with the presentation initially. So once it is done, we'll show you the how the software will to install, and after that, you can start on hands-on part. So, Vamsi sir, you can start.
Yes, good morning to all the participants from, this is Vamsi Kattamuri from Vignan Institute of Engineering for Women. Welcome you all to the day 4 session on advanced simulation tools for power electronics, electromagnetics and power systems. So today we will be dealing on the software called EMTP, where the domain goes to the power systems. So all the power systems and all the members should be able to use the software very easily, I hope. So I will, having said this, I will be handing over the session to, so I welcome Monica and Bhuvati sir to take over the session for this day. Thank you.
Thank you, sir. Good morning, everyone. My name is Monica, working as a power system support engineer in PwC Engineering Solutions Private Limited. Today we will go with the EMTP software features and applications. EMTP, it is an electromagnetic transient program software which is used to provide the solutions for all type of electromagnetic and electromechanical transients in power systems. It is a very advanced technical software. Here we can able to perform all type of electrical transients in the power systems. Before going in detail into the EMTP software features and applications, first we would like to know why we will go for the EMTP software. In all the power system networks, we know we have too many of transients because of the transformer energization or transmission line energization, cable energization, load rejections, switching transients and lightning transients, ferro resonance. Because of these things, we will get the switching and lightning transients. So it is very important to study those transients at that particular time. We can compare those transient values with the standard values. Finally, we can fix the insulation of our equipment. So it is very important to study the transients in power systems. So to calculate the solution for the time domain simulations, we'll go with the two types based upon the mathematical model analysis we are using. Here you can able to see the example for voltage is equal to L into di by dt. I'm writing the equation for the voltage of the inductor. So if we are considering the phasor domain, that means here we are performing the Laplace transform analysis, and we will get the voltage across the inductor frequencies like 50 Hz. For time domain simulations, we will go with the trapezoidal or backward Euler integration methods based upon the. Sir, are you able to hear? Hello?
Yes, ma'am.
Monica, we can.
Okay, okay, sir.
Audible. It's audible.
Okay. Yeah, in time domain simulations, we will go with the trapezoidal or backward Euler integration methods for performing the equations like nonlinear equations and other things. In this example, here you can able to see the trapezoidal and backward Euler integration equation for the inductance value. So you can able to see the difference between the time domain versus phasor domain softwares. For the phasor domain software, we will get here you can able to see the response of voltage or current it may be. You can able to see the red color waveform. For phasor domain analysis, we will get the response of magnitude and angle of in phasor domain analysis. But for time domain analysis, we will get the waveform for each magnitude and angle for each and every particular time instant. So here at 200 milliseconds, we will get the spike here, but in phasor domain, we will get a small spike. We can able to see that one. This is the classification of power system phenomenon. Here you can able to see the application of EMTP software from microseconds to seconds itself. We can perform the lightning, line switching, transients, subsynchronous resonance, transient stability, dynamic stability, normal load flow analysis, and short circuit analysis also we can perform by using EMTP software. These are the main EMTP applications. In main EMTP applications, we will go with the HVDC applications, FACS, subsynchronous resonance, power quality issues, geomagnetic storm, interaction between the compensation and control components. All the things we can able to see by using EMTP software. These are the some more applications, some related to grid integration, saturation problems, power oscillations for the protection systems, all the things you can able to see by using EMTP software. These are the main EMTP applications. In EMTP, we have different types of simulations are also possible. Load flow analysis, steady state analysis, time domain analysis, and frequency scan analysis. In load flow simulation, by using EMTP software, we can perform both balanced and unbalanced load flow simulations. For steady state and load flow analysis are used to initialize the time domain simulations in the EMTP software. So here in time domain simulations in EMTP, we are using the augmented Newton-Raphson method. Because of that augmented Newton-Raphson method, we can able to perform we can able to simulate all type of power systems, like from medium to large networks, small networks also. By using the augmented Newton-Raphson method, we can perform the analysis. Frequency scan analysis is used to find out the input impedance of the complete system from one frequency to another frequency. Like that, we can perform different types of simulations in EMTP software. Here you can able to see the application of EMTP software. We know by using EMTP software, we can perform the load flow calculations and short circuit calculations at particular frequencies, that is default frequencies. It is 50 Hz or 60 Hz it may be. If we are going for the transients, that means if we are going for the transients, we can able to perform from DC to kilohertz or megahertz also. If we are going for high frequencies, that means if we are going for the switching transient and lightning transients, the frequency should be in kilohertz and megahertz. That means we need to model the each component of the power system in detailed model. If we are considering the transformers, CTs, VTs, like that, if we are considered, then we need to model the saturation characteristics. If we want to model in detailed by providing the hysteresis of the transformer also, we can model by using EMTP software. Similarly, if we are going for the transmission lines and cables, we need to enter the RLC parameters. The inductance and capacitance directly depend on the frequency, that we know, but here the resistance also, if the frequency is increases because of the skin effect correction factors, the resistance of the transmission lines and cables are also varied according to the frequency. So in EMTP, we can model the transmission lines also in detailed model, like frequency dependent model, wideband models we can use. If we not require the detailed models, we will go with the constant parameter model, pi models. Different types of models of transmission lines and cables are also available in EMTP software. We can perform the HVDC modeling, FACS modeling. Similarly, we can provide the solutions from small to large networks. Different nonlinear devices are also present in EMTP software, like surge arresters and other things. So we can able to solve the solutions for nonlinear devices also by using EMTP software. This is the complete EMTP package. Here you can able to see the EMTP works is our graphical user interface. In this graphical user interface, for each and every software in graphical user interface, we can perform the modelings and we can able to go for the different scenarios. All the things we can do in the graphical user interface. EMTP has a powerful and super fast computational engine to solve the modelings and other things. For Kapu, we can able to see the output results like voltage, current, THD analysis, all the things we can able to see in the Kapu. In EMTP, this Kapu is a advanced function editor is available as in the Kapu, so we can perform the post-processing analysis like we can able to perform the FFT analysis, DFT analysis, harmonic analysis, all the things we can able to perform directly by using the Kapu in EMTP software. So these are the add-on modules available in EMTP software. Exciters and governance library. In exciters and governance library, we have a different more than 50 standard models are available in EMTP software, along with some manufacturer models and IEEE standard models also. Along with the exciters and governors, we have a power system stabilizers, under voltage exciter, over voltage exciters. All the things are available in EMTP software. In protection toolbox, by using EMTP software, we can able to perform the protection analysis in both steady state and time domain simulations. In protection toolbox in EMTP, we have a different release are available. Some manufacturer release are available also, like ABB, Alstom. Some manufacturer release are also available. Overcurrent protection, we can able to perform the overcurrent protection, differential protection, distance protection, loss of field, out of phase detection. All the things we can able to perform by using EMTP software. Simulink toolbox. This toolbox is used to import the models from MATLAB coding and Simulink models into the EMTP very easily. LIOV toolbox. This LIOV toolbox is used to find out the or calculation of lightning induced over voltages on the distribution networks. PAMSUT toolbox. This PAMSUT toolbox is used to find the parametric analysis, sensitivity analysis, optimization, all the things we can able to contingency analysis also we can perform by using PAMSUT toolbox. Renewable energy toolbox. In EMTP, we have a single and wind and PV parks are also available in EMTP. So it is very easy to integrate the renewable energy sources into the power systems in EMTP software. These are the EMTP benefits. Here you can able to see the main benefits of EMTP software. We can perform the multi-phase unbalanced load flow analysis. Automatic initialization for time domain solutions is available. And one of the main important thing is a space matrix. Here we are using the space matrix method for solving the simulations. That means if we are increasing the number of components or number of nodes, number of passes in the modeling of a system, then it takes to simulate, it takes more time to simulation completion. So by using the space matrix, the simulation time is directly proportional to the exponential of number of components used in the complete model. So because of that, simulation time is also reduced for a large number of networks. And EMTP is also scriptable. We can do the programming by using JavaScripting also in EMTP software. It is having interfacing with some other simulation tools like MATLAB and ECAP interface are also available in EMTP software. This is the complete flowchart of EMTP software. Here you can able to model the graphical user interface. In graphical user interface, you can model your simulation model and you can perform the different scenarios here. So after that, we can enter the parameters as data in each and every component. So here you can see the rectangular box with the different analysis. You can perform any of the analysis here. You can perform load flow, steady state, or time domain. For results, you can go for the Kapu or mplot. For load flow analysis and steady state analysis, we will get the results on GUI directly. Mainly, we will measure the bus voltages and power flow through the system. Those things we can able to see in the GUI, EMTP GUI directly by using load flow analysis and steady state simulation. But for time domain simulations, we will go for the mplot and Kapu. These are the main EMTP references. So manufacturing companies are also using the EMTP software, and NTPC, at the power grid, all different power system softwares are using the EMTP software, and some universities like IIT Patna, IIT Delhi, and Anna University are also using the EMTP software. Now we will go with the application of EMTP software. Transmission line modeling. In EMTP, normally for modeling of transmission lines or cables, we require the RLC parameters of transmission lines, right? So if we know the RLC parameters, then directly we can enter those RLC parameters into the pi model or constant parameter directly. If we don't have the RLC parameters, or otherwise if we are going for the switching transients or lightning transients, at that time we will go for the detailed model of transmission line model. For that we will go for the transmission tower configuration, and we can enter the horizontal and vertical distance of the conductors in the transmission tower configuration into the line data. From the line data, the EMTP automatically calculated the generated parameters of RLC, and those RLC parameters directly we can input into the frequency dependent line or constant parameter line. It is a two-step process actually. And EMTP has a manufacturer database is also available. We will go in detail of the transmission line modeling when we are going with the hands-on session. This is the transmission line database already available in the EMTP software. We can able to see the different transmission line models from 66 kV to 735 kV with single circuit and double circuit transmission tower configurations are available in EMTP software. You can directly take these transmission database and you can generate the parameters you can import into the transmission line model. Similar to the transmission line, we have a cable model is also we can able to add the modeling the detailed cable models by using EMTP software. Similarly, here also we can able to add the inside and outside readings of the conductors and insulators, all the things we can able to model in the cable data. From the cable data, EMTP automatically generated the parameters and we can import those models into the wideband model or frequency dependent model, constant parameter model, like that we can able to import. The main application of EMTP software is lightning transients. Normally we know the lightning is two types, direct lightning and indirect lightning. For indirect lightning, we have a LIVOV toolbox is used. LIVOV module is used for find out the lightning induced over voltages on the distribution networks. For direct lightning, in EMTP we have a Sigrey current source model is available with in parallel with a high resistance value. By using this Sigrey current source model, we can able to add the Sigrey current source wherever we want in the system. Here you can able to see the example of the lightning transients. In this example, we are adding the Sigrey current source of 200 kiloamperes lightning stroke we have connected to the ground conductors here. So after that, for lightning transients, we can able to model the detailed model of the complete system. Here you can see the after the transmission towers, there is a AIS substation and GIS substation is available. For we can add the each and breaker capacitances, stray capacitances of CT and CVT, all the things we can able to add by using for performing the lightning transient analysis. After modeling the each and every component, here you can able to see the voltages at wherever you want in the system. So here in this example, we are adding the voltage meter here. So we can able to get the transmission tower top voltage. Similarly, we can able to see the energy absorbed by the surge arrestor at the time of transmission, at the time of lightning stroke induced. So because by using lightning transients, we will go with the what is the importance of footing resistance for the tower configurations, and we will go with the detailed models of lightning analysis. All the things we can perform by using EMTP software. Next one is switching transients. We are all know the switching transients are mainly because of the typical network events like switch energization of transmission lines or cables, fault appearance and its clearance, capacitor bank switching, reactor switching, load rejection, transformer energization. At the time we will get the switching transients. So it is very easy to study those switching transients. In this example here, we are energizing the transmission line L4. This is a frequency dependent model we have modeling, and we have energized this transmission line L4 with the trapper charges by using this breaker. So after that we can able to see the switching transients at the receiving end here. So at 50 milliseconds, we are closing the switch. So we will get the switching transients of the system like this. So similarly, if the fault is cleared, that means at the time of fault clearance, we are all know at the time breaker opening, there is a TRV and triple RV of the breaker occurred. So it is very important to measure the TRV and triple RV of the system. So in EMTP, we have a TRV breaker is available. In that we can enter our data like 2 parameter envelope or 4 parameter envelope, our own data, or you can take the IEEE or IEC standard TRV envelopes. So EMTP automatically calculated the fault current in your design system, and accordingly it will provide the TRV envelope of the system based upon the T10 load or T30 characteristics, T60 characteristics. It is taken automatically by internally, it will take and it will provide the envelope. Here in this example, you can able to see the red color waveform indicates the TRV envelope of the system, and the green color waveform represents the voltage across the breaker. So if the voltage across the breaker is less than the TRV envelope, that is within the TRV envelope, we can finalize the breaker has some protective margin is available with that breaker. Otherwise, we will go with the next breaker, or we can reduce the switching transients by using some techniques like we are adding the arresters, PIR method, or control switching. We will go with those switchings and we can reduce the switching transients. If we want to enable the restrikes or pre-strikes, it is possible to enable by using EMTP software. Similarly, we can include the stray capacitances also if we are going for the switching transients analysis. Next application is ferroresonance. Ferroresonance is mainly a nonlinear resonance which is occurred mainly due to the transformer inductance. Nonlinear inductance is in series with the cable capacitance or capacitance. So at that time we will get the ferroresonance in the system. So in this example you can able to see the transformer voltage here. So at the time of single pole stuck or two pole stuck, we will get the ferroresonance analysis. Because of the ferroresonance, the voltage or currents suddenly rise to some other steady state from the normal steady state. So from one steady state to another steady state it will reach. It will take more than 400 to 500 milliseconds. It will continue. After that it is reduced again. So it is very important to study the ferroresonance applications. In EMTP, we can able to find out the different types of ferroresonances like chaotic ferroresonance and achaotic mode. All the things we can perform. Similarly, for ferroresonance analysis, we need to model the transformer components. We can add the saturation characteristics based upon the input provided by the manufacturer or OCC and short circuit characteristics. We can calculate the flux versus current, and we can import those values, that means saturation characteristics, into the transformer directly. And similarly we can add the hysteresis characteristics of the transformer based upon the residual flux available in the transformer. Next application is transient stability. In this example, here you can able to see the synchronous machines connected to the AVR control modes. In this AVR control modes, we are added the exciter and governor and power system stabilizers, all the things we can add, and we are created as a sub-circuit. After that, the synchronous machines, it is connected to the long transmission line. Finally, it is connected to the equivalent grid. So in between there is a substations are available, generating stations are available here. The equivalent impedance of generating stations are added here. So by using the EMTP software, here we are creating a fault on the second transmission line, and we are opening the breaker, again reclosing the breaker, again opening the breaker. A lot of times we are opening and reclosing the breaker, and finally we are opening the main breaker of the synchronous machine connected to the transmission line. So in this example, if the main breaker Day-4 is connected to the synchronous machine 4 is opened after some time, while reclosing and opening of breakers. After that, we can able to see the remaining synchronous machine. After some time, it reaches to the steady state, and synchronous machine 4 is reached to the 0 value. Like this, we can able to perform the transient stability of the synchronous machines here. And for exciter and governors, we can directly able to see the subcircuit created in the exciter and governors library, and we can create it as a masked parameters. If you want to see the subcircuit and if you want to remodel the subcircuit, you can remodify the subcircuit and you can add your parameters directly. That means you can do your customizable models. Or otherwise, if you have a different like here, you can able to see that this is the subcircuit of governor here. This is created by our own self, like by using control functions and control functions library in EMTP software. We can develop our own subcircuit for the exciter and governors. We can add those as a separate library, and for future use we can use that library. This is the example for power electronics and facts. In this example, you can able to see the detailed modeling of STATCOM, SVC, and other things. We can able to see the subcircuits of each and everything. The detailed model of control techniques are also we can perform, and different examples are also available for this in EMTP software. In this example, you can able to see the absorbed power by the STATCOM and voltage at the capacitor bank. You can able to see. Next, HVDC applications. In EMTP, we have a different modular multi-level HVDCs are different levels of modular multi-levels are available. In this example, we are using 400 levels modular multi-level MMC we are using, and we have an average value model and detailed models are available. According to our requirement, we will go with the average value model or detailed models of MMC models, and we can able to do the HVDC applications very easily by using EMTP software. Next one is transformer energization studies. The main objective of the transformer energization studies is at the time of transformer energization, we have a inrush current. We can calculate the inrush currents and voltage drop at the time of transformer energization, and its validation of protection settings like overcurrent protection and differential protection of the transformer. All the things we can able to perform. For analyzing the transformer energization studies, we can finalize the validation of protection settings and other things. And we can perform the different scenarios. Normally in EMTP, we have a detailed models of transformers are also available, like BC-tran model, tree-leg model. We can able to model the transformer in detailed model, and we can perform the different scenarios like different residual fluxes like 0% or 80% residual fluxes, and different closing times of a breaker. All the things we can able to perform for different scenarios we can do. You can able to see the inrush current waveform here. This is the inrush current of the transformer with different scenarios, and this is the voltage at 11 kV bus. At the time of transformer energization, we will study the voltage drop at the transformer connected to that particular bus. Next one is the wind generation. For integration of renewable energy sources into the power system, it is very important to maintain the power quality issues. Measure the issue is the power quality issue. So for going for the power quality issues, we need to model the PV parks or wind parks, single PV panels. All we can model as a harmonic models. If we know the harmonic spectrum of wind turbines, then we can add directly the harmonic spectrum. Otherwise, for detailed models, we will go with the normal analysis like time domain analysis. We can add and we can perform the fault. We can create a fault and we can able to see the power flowing from the wind turbines and voltage at the power. So in this example, we have calculated the total harmonic distortion here, THD value, and we can compare those THD values with IEEE standard 5 or 9. So you can see at the 22nd order, we will get the high value compared with the IEEE standard value. So basically, because of the at 22nd order, we will get the high value of current harmonic. So we will add the filter at one of the bus. Accordingly, like this, we can able to finalize the filter value and we can calculate the filter size and other things we can add at the bus to minimize the harmonics value. So this is the detailed modeling of wind turbine here. So for each and every wind turbine, we have connected through ZNO arrestor and fuse, and it is connected as a converted as a sub-circuit, and we can connect. This is the detailed model of wind turbine. We can able to see the sub-circuits of the wind turbine here. What is the converter controls and DFIG controls, all the things we can able to see directly by using in the EMTP software. This is the EMTP RV wind park benchmark system. In this example, we have connected the offshore wind parks, onshore wind parks, all the different wind parks are we have added, and synchronous machines. HVDC system is also available in this example. We can see that one example, default example is available in the EMTP software. Similar to the different examples, we will study the subsynchronous control interaction techniques are also studied we can in EMTP software. Subsynchronous control interactions, that means what is a subsynchronous resonance? First we know the subsynchronous resonance. What is it? Whenever the wind generation or wind turbines are connected in series with the series compensated transmission line, then we will get the subsynchronous resonance oscillations in the system. In this example, at 2.1 seconds, we are opening the transmission line due to the fault at 2 seconds. So after opening the breaker, that means after 2.1 second, whatever the wind turbine connected in the system is in series with the series compensated transmission line. 500 kilometers transmission line is there here. It is a series compensated transmission line. Because of the series connection of transmission line in series with the DFIC wind park here, you can able to see the current, wind park current after 2.1 second. We will get the frequency as 24 hertz. It is below the normal frequency, default frequencies. Because of that, we can finalize this as a subsynchronous control oscillation, subsynchronous resonance. We will get the subsynchronous resonance here. Like this, we can able to perform the subsynchronous control interactions also. Next one is protection. In normal softwares, we can able to perform the protection analysis by using in steady state. Here in EMTP software, we can perform the protection analysis in both steady state and time domain simulations also. Here the waveform represents the time domain simulation protections here. Here we are, in this example, we are creating a fault at this load 2, and we are opening the breaker and again reclosing the breaker and again reopening the breaker because of the fast and slow neutral protections added in that relay value. So we can able to see the currents of CT currents or relay currents here. This is the example for the overcurrent protection. Here you can see. Next example is the differential protection. At the time of transformer energization, we have a induced current or a differential current flowing through the differential relay. So here in this example, we have measuring the CT current, CT secondary currents. We have measuring CT1 and CT2 secondary currents, and similarly we have measured the differential current flowing through this differential relay. So after calculating the differential current, we will go with the FFT analysis in the scope view, and we can calculate the what is the second harmonic inhibit value, and we can add that second harmonic value in the differential relay to avoid the operation of differential relay at the time of transformer energization. Like this, we can perform the differential protection for the transformer. Next one is the distance protection. So in EMTP distance protection, we will find the RX graph also. So based upon the zones we have used, and 75%, 25% zones we have added in the different distance relay, and we can go to the RX graph and we can create a fault, and we can able to see that fault is located, switched into which type of a zone, that is zone 1 or zone 2. Directly we can able to see in EMTP software. Similar to the distance protection, we will go with the loss of out of field, loss of switching, all the things, loss of swing, all the things we can able to see in EMTP software, and we have a different default examples are also available for each and every session, like TRV analysis, transformer energization, detailed models of transformer for BC tran model, and like ferroresonance applications, HVDC applications, protection examples, or different examples are available in EMTP software. Okay, now we will go with the hands-on session. Before that, just I would like to tell the how to install the EMTP software. I hope all the people have downloaded the EMTP software, right?
Has issues, Monica, so you can show them how to install.
Yeah, yes, sir.
once.
Hope you got the links for a EMTP demo version and MCR compiler. So just you can download the EMTP demo version and you can install. Just you can download the zip file here. Just you can extract the files. Just you can extract the files of EMTP demo version. Just you can extract the files. So after extracting the files, there is a setup file is available in the EMTP demo. Just you can double click on that setup file. I hope all the people are getting the links to download the EMTP software. Just you can click on that link. You can able to see the folders there. EMTP 4.1.0 and demonstration guide and license file. Just you can download that one. After downloading the files, just you can extract the EMTP 4.1.0 demo zip file. Just you can directly right click and there is a extract here is available. Just you can click on that extract here. So after extracting, you will find the .exe file, setup.exe file. After extracting the files, just you can double click on that setup file and install the software. Just you can double click on the file. .exe file what is available. Just you can double click on that and you will get one pop-up message. Just you can click on S. After double click on the setup.exe file, you will get one pop-up message. Just you can click on S. I'll explain again. Just you can download the software from the link available to your mail. We have provided the link to download the EMTP software. Just you can go to that link and you can download the software. After downloading the software, just you can extract the files. by right click and extract here. After extracting the files, you will get the EMTP works 410 setup underscore demo.exe. .exe file you will get, setup file. So after extracting the files, just you can double click on the EMTP works setup.exe file. Just you can double click on that. One pop-up message is available. So you can click S. After click on S, you will get the EMTP work setup. Just you can click on the next. And you can enable the terms of this license agreement. After double click on the EMTP work setup file, you will get the pop-up message. You can click on that S. After that, you will get the one EMTP work setup file is on your desktop. Just you can click on the next. Just you can click on this next. After double click on the setup file, you will get the pop-up message. Just you click on that S pop-up message S. After that, you will get the EMTP work setup, and you can click on next, and you can enable the I agree to the terms of this license agreement. Just you can enable that one. After click on next, just you can enable or you can select the license agreement. Just you can click on the license agreement and click on next. Again you can click on next. And again you can click on next. Finally you can click on next for installation. Who are the persons not able to install the software? Just you can install now. Just you can extract the files from the downloading file, and you can double click on that setup file. And we have added the EMTP demonstration installation guide also. Just you can follow that installation steps. Just you can follow the EMTP demonstration installation steps here. We can provide the installation guide. Or you can double click on the setup file and click on that pop-up message yes. After that, just you can click on next button and you can enable the agreement for license agreement. After click on next, just you can agree the license agreement and next. Again next, next, and finally you can click on next to proceed the installation. So you proceed as the installation will be started. So for me it is already installed, so it is asking for again reinstalling. For you it is not asking, just you can install by clicking on the next tabs in your pop-up messages. Just you can agree for the license agreement and you can click on the next. Finally you can install the EMTP software. After the installation of EMTP setup file, just you can go to the EMTP activation utility. After the installation, it is directly so just you can go to the EMTP activation utility. After the installation,
Hello.
Yeah, hello sir.
Madam, tell me what to do, madam?
So after you are going,
Okay, I got same paper.
Hello.
Madam, I installed, madam.
Okay.
Then same page. You are getting the same page. I also getting same page, madam. Same page, madam.
Okay.
After, madam.
Okay, sir. After that, just you can, yeah. After that, just you can click on that EMTP import license file.
Import license file.
Yes, sir.
Okay, madam.
Just you can click on that import license file, and you can browse. In the yesterday's link, you will find the EMTP RV license file.
File name.
EMTP RV license.lic file you will find. Here you can see, sir. You can import this license file to the EMTP activation utility. In the yesterday's link, there is a EMTP RV license file.lic file is available. Just you can go to the EMTP activation utility and you can click on that import license file. Just you can click on that import license file and you can browse that file. Just you can open this EMTP RV license file and click open.
Madam, it is telling feature missing is telling, ma'am.
It is coming
It
feature.
is telling us it's.
Okay, sir.
Yes, ma'am. Feature missing.
Okay.
Can you just share the file in the group, ma'am, in chat if possible? Can we share the chat and group file in the chat?
Okay, sir. I will share. Okay.
Okay.
Yes, I can share the license link. Just you can go to click on that link and you can download and you can add that license file. Just you can import that license file.
Hello?
Yeah, hello sir.
Hello, madam.
Yeah, hello
Madam,
sir.
it tells feature missing. Feature missing, madam.
Okay, 1 second sir.
When you are open the
Okay, 1 second sir. I'll also try that one again. Training emotion. Okay. Feature missing.
yes, ma'am, like that. Feature missing.
Okay sir, one thing you can do, just you can go to the C drive.
Ma'am?
You can go to the C drive.
Okay, ma'am.
Yeah, there is a program data folder is available. Just you can click on that
Just a
Yeah, okay sir. You can double click on that program data.
in C drive, ma'am.
Yes sir, in C drive.
Program files, ma'am.
Program data, sir. Program data folder.
I had program files and then program files, ma'am.
Okay, after program files, you didn't find the program data, sir?
No, ma'am.
Okay.
Monica, is this 64-bit, whatever you shared?
Yeah?
Is it works in 64-bit? 64-bit system, or it works with 32-bit also?
64-bit system, sir.
Okay. I think, sir, what type of system you are using, 64-bit or 32-bit?
64-bit, sir.
So only you are facing the error. So for you part, I think it will be difficult for us to stop the session. So we'll continue the session, sir. So once it is over, we'll share you the recordings and everything. So you can write us a mail. Kindly share your contact details. So Monica will contact you after the session and she'll explain.
Okay, sir. Okay, sir.
Okay. So Monica, you just continue, please.
Okay.
Madam, what we do in program data, ma'am?
No, sir. If there is a program data is available, there is a PowerSys folder is there in the program data.
PowerSys, ma'am.
Yes, sir. In the program data, there is a PowerSys folder is available. So after installation of EMTP software, it shows the EMTP Works folder, EMTP Works 4.1. So just you can double click on that folder and you can paste the license file here. Then automatically the EMTP is opened.
Okay.
Yeah, you can do like this also. And one more thing I will share, you can try that one also, sir. Otherwise, after the session, I will go with that. Just you can click on that activate demonstration mode. In the EMTP activation utility, just you can click on that activate demonstration mode.
Yes, ma'am.
Yeah, after that again it is asking for the activate demonstration mode. Just you can click on that activate demonstration mode again.
Okay, ma'am.
Yeah, then you will get the pop-up message like this action will replace the license information. Just you can click on that S. Yeah, after click on S, you will get any license information, sir.
It is not working for me, ma'am.
Okay, sir. After the session, I'll discuss with that, sir.
Okay, ma'am.
Okay, sir. I will just yeah.
The license file has been saved to see program data or system. You can start using EMTP. Is it okay, ma'am?
Yeah, yes, sir.
After that, I have to click on OK, ma'am.
Yeah, you can click on OK.
Okay.
After opening the, just you can click on the EMTP works. Just EMTP.
On start one.
In the start menu, just you can type EMTP works for opening the, just you can click on the EMTP works.
Okay, EMTP. .NET framework to run this application, you first must install one of the following versions of .NET framework. Contact your application publisher for instructions.
Okay, sir. Some systems it requires the .NET framework. Directly we can download the .NET framework from the website Google. Yes, you can download and you can open the EMTP software.
Okay.
For some of the systems only, it is asking for the installation of .NET framework. Yes, you can directly open the browser and you can type .NET framework and you can install the latest version of .NET framework. You can install the latest version of .NET frameworks. After that, you can install the EMTP software. Okay, whoever install the software, just open the EMTP works in the start menu. Just you can click open the EMTP works. After opening the EMTP works, here you can able to see the opening of EMTP works here. So if you want to open the already existed file, just you can click on the browse for file, or if you want to open the recent files, then you can open directly the recent files. So you can drag some more, then you can able to see the different example files already available here. Default example files are available for exciters and governors, protection, renewables, exciters and governors, application cases. In that application cases, you can find the examples for corona, ferroresonance, HVDC, some IEEE examples, harmonics examples, lightning transient examples, switching examples, line energization examples, transformers, TRV analysis. All the examples you can find directly. Some default examples are available. So if you want to open the examples, you can use this. Now, just you can create a new default document. Just you can create a new default document. Just you can click on the new. Just you can create a new default document. For that, just you can click on that new tab and click on the EMTP default design and create. Now you can open the new file. For that, just you can click on that new in the file tab. In that you can click on that EMTP default design and click on the create. Just you can open the new file. In the file tab, you can find the new. Just you can click on that new. Select the EMTP default design and create. After opening the new file, here you can able to see this one is the EMTP GUI. We can perform the modeling here. Right side, you can able to see the libraries. Different libraries are available. You can directly see in right side parts by library. So first I can create a simple RLC circuit here. First I can create a simple RLC circuit here. For that, just on the right side you can able to see the RLC branches library. On the right side you can see the RLC branches library. So you can double click on that RLC branches. For that, just you can, on the right side you can go to the RLC branches library. You can double click on that RLC branches. You can take R, L and C components from there. Just you can double click and drag into the GUI. Just you can double click on the component and drag to GUI. And you can take the C non-polarized. So both C non-polarized and polarized are different, same. The only difference is representation of the capacitance here. Just the symbol is different. Just you can take the RLC non-polarized. Just you can go to the, on the right side you can find the RLC branches library. You can double click on that RLC branches library. And you can take the components of R, L and C. For that, just you can double click on that R and drag to GUI. After that, just you can click on that escape button, it will close. Just you can double click on the component and drag to GUI. So after that, there is another inductance is on your mouse. So here, just you can click on that escape. After taking the RLC components, next you can go to the sources library. After dragging the RLC components into GUI, just you can go to the sources library. Take AC voltage source 3 phase. After tagging the components of RLC parameters into GUI, just you can take the AC voltage source 3 phase. You can take the AC voltage source 3 phase and you can connect. Like this you can connect directly. Just you can select one side of the component and you can drag to other side of the component. For connection, just you can click on one side of the component and drag to next component side what we have connected. So for connection of this capacitor, I can add one switch here. So you can able to see the switches library right side. Just you can double click on the switches library. Just you can double click on that switches library. You can take ideal switch or ideal switch with breaker symbol, both are same, only difference is the symbol. Just you can take any one of the switch, ideal switch or ideal switch with breaker symbol, and you can connect. After dragging the RLC components into GUI, just you can go to the sources library and take AC voltage source 3 phase. And you can connect the components like this. So the other end of the capacitance, I can connect the ground. So you can find that ground in RLC branches. In RLC branches library, you can find the ground. So just you can connect the ground. in the RLC branches, you can find the ground. So you can connect the ground. So after connecting the circuit, RLC circuit, just you can double click on the component to import the parameters. Just you can double click on the component for importing the parameters. Just I am changing the voltage to 33 kilovolts. After that, just you can double click on the component for entering the values. Double click on the voltage source 3 phase and change the voltage from 33 kilovolt. Change the voltage to 33 kilovolts and frequency to 50 hertz. Just you can change the voltage to 33 kilovolts and frequency to 50 hertz and click OK. For the resistance value, just you can double click on the resistor and you can increase the resistance value to 5 ohms. And you can enable the select nominal frequency, change the frequency to 50 hertz. Just you can double click on the resistor and you can increase the parameter to resistance parameter to 5 ohms. And you can enable the select nominal frequency Fn and change the frequency to 50 hertz. Change the frequency to 50 hertz and click OK. After that, just you can double click on the inductor and increase the inductance value to 10 millihenries. And you can change the frequency to 50 hertz. Just you can double click on the inductor. For A phase only, you can enter the value 10 millihenries. Right side you can see the units. You can change the unit to millihenries and you can enter the value as 10. So because of this enable of balanced gap, you need not to enter the phase B and phase C values. Automatically it will take in. So just you can enter the 10 millihenries in the phase A and change the frequency to 50 hertz and click OK. After that, just you can double click on the capacitor and change the frequency to 5 microfarads. After that, just you can double click on the capacitor, change the frequency to 5 microfarads, and you can enable the frequency and change the frequency to 50 hertz and click OK. Just you can double click on the each and every component and you can enter the resistance value as 5 ohms and inductance value as 10 millihenries and capacitance value as 5 microfarads. After entering the parameters of RLC, just you can double click on the switch. You can double click on that switch and you can close the switch at 30 milliseconds. Just you can double click on the switch and there is a T close is available. Just in the T close you can add 30 milliseconds. That means I can close my switch at 30 milliseconds and click on the never open. Just you can close the switch at 30 milliseconds and click on that never open button and click on that never open. Just you can double click on that switch and you can close the switch at 30 milliseconds and click on the never open. So it will take too much time to open the switch. It gives a very large value when clicking on the never open. And click OK. After connecting the circuit, just you can double click on the parameters of each and every component. Just you can click on that, double click on the component for entering the parameters. You can enter the resistance value as 5 ohms, inductance value as 10 millihenries. Right side you can see the units button. You can enter the inductance value as 10 millihenries. And you can enter the capacitance value as 5 microfarads and click OK. Finally, you can go to the switch, double click on that switch, and you can close the switch at 30 milliseconds and click on never open and click OK. After connecting the circuit, to see the output responses of voltages and currents, so right side you can see the meters library. So to see the output results, right side you can find the meters library. From the meters library you can take the voltage scope 1 pin. From the meters library you can take the voltage scope 1 pin and you can connect it the capacitor. So I want to measure the capacitance voltage. For that, just you can go to the meters library and take the voltage scope 1 pin. From the meters library, just you can take the voltage scope 1 pin and you can connect it the capacitor. After connecting the voltmeter at the capacitor, I want to see the results flowing current flow through the switch. For that, in EMTP, for each and every component, just you can double click on the switch. In EMTP, for each and every component, you can find the scopes tab. Just you can go to the scopes tab and you can click on the select all at the current. So in EMTP, we have a scopes tab is available for each and every component. Just you can double click on the component and go to the scopes tab and you can click on the select all. Just you can click on the select all and click OK. So now I can able to see the current flow through the switch and voltage at the capacitor. Output voltage at the capacitor and current flow through the switch. For output voltage at the capacitor, I have connected the meter voltage scope 1 pin from the meters library. Voltage scope 1 pin from the meters library you can take and you can connect. So to see the current flow through the switch, just you can double click on the switch, go to the scopes tab and you can enable or select all. Just you can click on the select all for the current flow and click OK. Now I have connected a simple RLC circuit here. If you want to know whether all the components are connected or not, if you want to check, for that, just you can click on the control button in your keyboard to see whether the connections of each and every component is connected perfectly. For that, just you can click on the control button on your keyboard and double click on any one of the components. To check the connections are perfect or not, for that, just you can click on that control button in your keyboard. Just you can click on the control button. You can press the control button in your keyboard and double click on any one of the component. And you can double click on any one of the component. Then the complete circuit is highlighted with a green color. and the components are highlighted with a black color. That means your system is perfectly connected. After connection of the RLC circuit, just you can go to the simulate tab. Top side, you can go to the simulate tab. And after connection, just you can save the simulation. Just you can save the simulation by using Control S. After completion of your connection, just you can go to the save. You can save your file. For that, in the home tab, you can find the save and save as. Just you can click on the save. And you can enter the file name as RLC and click on the save button. Just you can save the file. For that, in the home tab, you can click on that save button, or you can use Control S for saving the file. Just you can use the Control S also. So after that, after saving the file, just you can go to the simulate tab. You can click on that simulation options. After saving the file, just you can go to the simulate tab and simulation options. You can click on that simulation options. And you can increase the time domain simulation to 10 microseconds and your simulation time to 100 milliseconds. After that, just you can go to the simulate tab, simulation options, and you can enable the time domain simulation, and you can change the main time step to 10 microseconds and maximum simulation time to 100 milliseconds, and change the default power frequency to 50 Hz. You can change the main time step to 10 microseconds and simulation time to 100 milliseconds and default power frequency to 50 Hz and click OK. After completion of the circuit, just you can save the file by using Control S or save button in the home tab. Just you can go to the simulate tab. After saving the file, you can click on that simulation options and you can increase the main time step to 10 microseconds and simulation time to 100 milliseconds and click OK. And you can change the default power frequency to 50 Hz also. You can change the main time step to 10 microseconds and simulation time to 100 milliseconds and default power frequency to 50 Hz and click OK. After that, just you can run the simulation. After that, just you can click on that run the simulation. After that, just you can run the simulation. There is a play button is available in the simulate tab. Just you can click on that run. So to see the output results, whoever the person install the MCR compiler, just click on the view scopes with mplot. Who are installed the MCR compiler, just you can click on the view scopes with mplot. Just you can click on that view scopes with mplot after run the simulation. After run the simulation, just you can click on that view scopes with mplot. So to see the output results in mplot, it is necessary to download and install the MCR compiler for demonstration mode. So after clicking on the view scopes with mplot, you can find this one. So the mplot is open for me. So here you can able to see in the scope type, you can able to see the node voltage Vn, it is represented as Vn, and switch current is Is. In the RLC circuit, just we are adding the outputs of voltmeter and the switch current. So in the mplot output, you can able to see the results for node voltage and switch current. So just you can go to the node voltage. In the node voltage, you can able to find the name as M1A, M1B and M1C. So three phases ABC, you can see the node voltages. This M1 represents the voltage meter name. So the voltmeter name here it is represented as M1. So in the output, you can find the node voltage as M1A, M1B and M1C. So you can select the M1A and click on y-axis. Similarly, you can select the M1B and click on the y-axis. And M1C, you can click on the y-axis. Just you can select the node voltages and click on the y-axis here. And you can able to click on plot. After that, just you can click on that plot. And you can able to see the responses in the waveform. You can see at 30 milliseconds we are closing the switch. So at 30 milliseconds we are getting the switching transients here because we are energizing the capacitor bank. That means we are closing the switch at 30 milliseconds means we are energizing the capacitor bank at 30 milliseconds. So you can able to see at 30 milliseconds we are getting the switching transients. Like this we can find the waveform in the mplot. After that, just you can go to the switch current Is. In the scope type, you can go to the switch current Is and you can clear these responses. For that, you can clear. To clear the responses in the right side, you can click on that clear button. Just you can click on the clear button. After that, you can select the switch currents. Switch 1A, 1B and 1C are here. Just you can click on the switch 1A or you can select the three waveforms by using control button in your keyboard. Just you can select the three waveforms switch 1A, 1B and 1C by using control button in your keyboard. Just you can click on the control button. You can select the three waveforms. After that, just you can click on the y-axis. After that, just you can click on that y-axis and you can click on that plot. After that, just you can click on the y-axis and you can click on that plot. So at 30 milliseconds, you can able to find the inrush current of the switch. So at 30 milliseconds, you can find the inrush current flowing through that switch. After that, it reaches to the steady state. Like this, we can able to see the response of RLC circuits in the mplot. Like this, we can able to see the responses of RLC circuit, simple RLC circuit in the mplot. I hope who are installed the software and who are installed the NCR compiler will get these responses right. Like this, we can connect the simple RLC circuit and we can find the responses of voltage and switch currents at the time of 30 milliseconds in the M plot. Like this, we can connect and we can see the responses in the M plot by installation of MCR compiler. For demonstration mode of software, we can able to see the responses in M plot only. For that, you need to install the MCR compiler and you can find the responses of voltage and switch current and you can analyze. Like this, you will get. I hope all are getting these responses for simple RLC circuit. So we can end this session today. Tomorrow we will go with the transmission line modeling and its energization, load flow analysis, short circuit analysis. Just we can take a one circuit and we can do all this load flow analysis and short circuit analysis. After that, we can go with the protection coordination. Simple examples we can do tomorrow. Today, if you have any doubts, you can ask. So meanwhile, for tomorrow's session, all of the people, can you please install the software? Just I will explain again how to install the software. For yesterday's link, I have shared with you. In that, you can find the files. Just 1 second. Yeah, you can find the EMTP demonstration installation guide and demo, that is setup file, and EMTP RV license file. You have received 3 files and you can install the software. You can .exe file you can install and you can see the installation guide available in that link. Accordingly, you can install the software and if possible, you can import the license file directly in the EMTP activation utility. Just you can import the license file. Just you can click on that import license file and you can browse that license file, EMTP RV license file on your desktop, whatever you have saved on your desktop or some other drive. Just you can import this license file into the EMTP activation utility and click OK. That is the one type. If it is not possible for you, just you can go to the C drive. After the installation of software EMTP 4.1 demo version, you can find the program data folder. You can find the program data folder. Just you can double click on the program data. You can find the PowerSys folder here. So just you can double click on the PowerSys folder. In that PowerSys folder, after the installation, you can find the EMTP Works 4.1. This folder is available after the installation of software. Just you can go to the C drive and go to the program data. In the program data, you can find the PowerSys folder. In that PowerSys folder, you can find the folder with EMTP Works 4.1. Just you can double click on that folder and you can save the license file here. Just you can copy and paste the license file into the EMTP 4.1 folder available in the program data PowerSys. Like this, you can import the license file into EMTP Works directly. This is the another one. Just you can try this one. If it is not possible with EMTP activation utility, you can try this. So to download the software, it requires a 64-bit system. So before installing the software, just you can check your updation of your system. If you have any Windows update, just you can, in the Start tab, you can select the Windows update settings. Is there any updation is available? Just you can update your Windows. Just you can update your Windows. After updation only, you can install the software and you can import the license file.
Madam, how to update the software, madam? Window, madam. Hello.
Yeah, hello sir. Just you can in the start menu, just you can type Windows update. In the start menu, just you can go to the Windows update settings. Just you can type
Start menu, madam. Where is it start?
Here sir. Downside you can find the start menu. Otherwise, just you can go to the settings. In the settings, there is an option of Windows update. So you can click on that Windows update. If you have any Windows update is there, just you can update your Windows and you can install the software again. Yeah, today you can try with this. You can install, you can update your Windows, you can install the software and you can import the license file. For importation of license file, I can say two types. One is just you can go to the EMTP activation utility and you can click on that import license file. If you have any feature missing as an error, then directly you can go to the C drive, program data. In that program data, you can find the PowerSys folder. In that PowerSys folder, you can find the EMTP Works 4.1 folder. Just you can double click on the EMTP Works 4.1 and you can paste. You can paste that file. License file you can paste. Like this, you can import that one. If for some of the systems only, it is asking for .NET framework. So to those persons who are asking for the .NET framework, just you can go to the browser. Just you can browse directly in the Google .NET framework 4.5, and you can download the .NET framework and you can install this one. It takes very 5 minutes process it is only. So just you can install the .NET framework. After that, just you can reinstall the software of EMTP software. So you can do this one today and you can work on the simple RLC circuit if you are install the software. If you have any doubts, you can ask tomorrow. And tomorrow we will go with the transmission line detailed modeling and load flow analysis, short circuit analysis, and protection coordination. If possible, we will go with some default examples already available in the EMTP software. We will go and we will see directly from the examples itself.
Excuse me, ma'am. If possible, can you demonstrate the renewable source integration, ma'am, tomorrow, if time permits?
Sure, ma'am. Sure. Okay, ma'am.
Okay, ma'am. Okay, ma'am. Just we want to know the application.
Sure, ma'am. I will explain. Yeah.
How to grid integration, ma'am. Only for that purpose.
Yeah, sure.
Yeah, ma'am.
Sure,
Okay,
ma'am. I will tell tomorrow. For demonstration mode, it is not possible. For you are not able to do that one. I will explain in software.
Okay.
If anyone are interested, you can
Okay.
apply for the trial version. We can provide the 15 days trial version for that.
Okay,
Tomorrow,
ma'am.
yeah,
Is that free, ma'am?
yeah, 15 days trial version is free, ma'am.
Okay, ma'am. Okay, ma'am. Thank you, ma'am.
Okay. Okay, everyone. Shall we end the session? Or if you have any doubts, you can ask.
Hello, ma'am.
Yeah, hello, ma'am.
This EMPT is used in a power grid.
Yeah, yes, ma'am. In power grid means what type of application you require?
Power grid means it is interconnected with different types of generating stations. Whenever there is a fault occur, how this EMPT recognizes there is a fault occur?
Okay. That is also possible, ma'am. We have a traveling wave detection methods are also available. Traveling wave detection examples are also available. If you want to find the fault, or at the time of fault, if you want to be able to see the transient stability of synchronous machines or some other renewable energy sources what is connected to that power grid, you can directly able to see the transient stability responses of each and every response. You can directly see, ma'am.
How this software is linked with all the devices in the stations like relays or a circuit breakers, CTs and PTs. What are the values? How this software is recognize the values or magnitudes?
Yeah.
How interface with these devices?
Yeah, yes, ma'am. For that, we need to model the each and every component in the system. Whatever the components in your substation or in your transmission system, just you can model your each and every component. Here you can, in the library, you can able to see the different protection.
Yes, ma'am. In this software, we are giving the values whatever we require and design all the models. But in a power system, there is the components which are we visible. How this software know the fault like magnitude?
I think this is not a real time software, na? Means
Yeah.
SCADA, like a SCADA, it's not a real time.
Yeah, it is not a real-time software. You need to model the component, whatever the scenarios or whatever the analysis you need to perform, you can perform.
Okay.
Yeah, exactly.
For analysis, for knowing the whatever we giving the values to know the what output we require.
Yes. What
Just
is the
for
output
analysis
you?
purpose.
Yes, yes. What is the
Yeah,
output
this
you
is
get?
only for the analysis purpose.
Yes.
Okay.
Whatever the output you get, and you can compare it with the standard values or your breaker standard values or insulation equipment values you can find. And if possible, you can add and you can analyze the systems.
Yeah, means before installation we can use this.
Yes.
Before installation of any switch yard or anything else,
Yes,
we can use this.
Yes, it is right.
But what software is used in the power grid for knowing a fault analysis, like which practical analysis?
I didn't get you, ma'am.
In
I think
power
there is a
grid.
SCADA system, no?
Okay. Okay. Thank you, ma'am.
The for the real time analysis, the SCADA system is used.
Yeah.
Okay. Thank you. Thank you.
Thank you, ma'am.
Dear participants, do you have any doubts? You can just ask Monica, ma'am. Shall we end this session, ma'am?
Yeah. Okay,
Okay.
everyone. Goodbye. Have a nice day.
Before ending the session, please fill the feedback form because that is being present in the chat box. Please fill the feedback form.
This software note down all the participants' attendance details. So please be attend till ending of the session. So based on this attendance, we are issuing the certificates. Thank you.
Thank you, sir. Thank you, Monica, ma'am, for your enormous explanation of the EMTP software. Thank you very much, ma'am.
Thank you, sir.
Thank you, ma'am. can end the session, ma'am.
Okay, sir. Okay, thank you, sir.
Wait 2 minutes, sir. Wait 2 minutes. We'll
I think
provide,
they are filling the forms, like some feedback
Okay,
forms.
okay.
filling the feedback forms. So wait 2 minutes. After 11:42, close it, ma'am.
Okay, sir. Okay, thank you, sir. Okay, I close after
Thank
2
you, ma'am.
minutes.
Thank you for a wonderful presentation. Thank you.
Thank you, sir.
Hello, ma'am.
Yeah, hello, sir. Sir, your voice is not audible. Hello?